Alright, sorry about the delay. I'll go an extra half hour. Oh, if looks could kill, I just died. Alright. If I remember correctly, but first, let me do one thing. So I know when I'm doing the videotape where I am. Got to do this earlier. Alright, first of all, good news. I finally figured out, mastered and everything last night. 11 o'clock I finished up. The new software the school now provides for video editing is quite good but quite complex. I finally mastered the last part. So within about a week or so, all the videos I've been taking, I'll be posting on YouTube. I'll put a link up there, and that should help you. All right. Last Wednesday, I was talking about molar mass. And molar mass for a compound is the sum of the atomic weights of all the elements in that compound. And I will not call it molecular mass, I'll call it molecular weight, abbreviated by the initials MW. Now, it's practice time. Did I do water last time?
Yes.
Nope. Did I? Did I do ammonia? All right, now I know where I went. All right, so the question would be, what would be the molecular weight of ammonia? Well, you need a periodic table. Let's get one up. Periodic table, and if you look at the different elements, you'll see, like for hydrogen, underneath the name, you'll see a number. That's the atomic weight. Now, remember my gift to you, a little gift, but a very nice gift, is on test 2, 3, and 4, and the final, it will say, please use proper significant figures for all calculated answers, and test 2 will now also say, please use all atomic masses to 3 significant figures, and you know how to round things off. And therefore, 1.008, the 3 significant figures is 101, so if I'm trying to find out the molecular weight of ammonia, there are 3 hydrogens, each one is 1.01, which is 3.303, and then 1 nitrogen. And if we go over to nitrogen, you'll see on the periodic table it has 14.007, but the 3 significant figures, that's 14.0 times 1 is still 14.0. I add it up, and what you get is 17.03. Now that's not the correct answer. Remember, for addition, you look only to the right of the decimal point. And we look at the 2 numbers we're adding. Your final answer has the same number of significant figures to the right of the decimal point as the number you're adding that has the lowest significant figures past the decimal. All zeros after decimal are significant, So this has 1, 2, which is lower 1. You come down here just past the decimal. This is 1, and I round off. It's 4 or less. So the correct answer is 17.0. And that's how you do molecular weight. And being a nice person I am, I'm going to let you try one, and that's sodium hydroxide. A very important chemical in the chemical industry. And in case you didn't bring your periodic table, which you don't, if we look at sodium, I'll help you out. If we look at oxygen on here, it's 15.999, and rounding that off to 3 significant figures, hopefully you all got 16.0. What's the molecular weight of sodium hydroxide? If you didn't bring a calculator, don't know how to add in your head, just write the numbers down how you would do it, and then I'll do it. All right, I think everybody's done. Let's do it. How do you figure out the molecular weight? It's the sum of all atomic weights. Since I have 1 sodium, 23.0. I have 1 hydrogen, 1.01. I have 1 oxygen, 16.0. And this is 0.1. This is 40.0. I know this one by heart because I use this number a lot. And if we look at this, what's the proper answer? Not this. This has 1 past the decimal, 2, 1. What's the lowest number? Hopefully I'll pick 1 past the decimal. And therefore I keep this, use that to round off, it's 4 or less. So sodium hydroxide, the molecular weight is 40.0. Now let's do one more. And I already have sodium on the board, and I'll let you try rounding off things. Here's chlorine. No, it's not. Here it is. And a mouse that's got a mind of its own. There you go. What would be the molecular weight of sodium chloride? Didn't move it. What?
You move your mouse so I can see the whole number.
You round it off to 3.
No, you're covering the number. Or the mouse.
You can see it right here.
Oh, okay.
Okay? That's the one nice thing about this periodic table. Whenever I put the cursor over, you can see up here. Okay? But you're right, I am. It's the same. All questions are good questions. I hope you all enjoyed Friday's World Fastest Lab. on this Friday, don't forget, it's a regular lab, you'll be working with chemicals again, so you need to wear proper clothing, don't forget to bring your safety goggles. All right, let's do this. What's the molecular weight of sodium chloride? I have 1 sodium, 1 chlorine, 23.0. If we look over here, how do you round that off to 3 significant figures? Keep the 3, keep the 5, keep the 4. After the 4, there's a 5. Is that 5 or higher? The answer is yes. So the correct answer for the atomic weight of sodium chloride is this. This is 1 past the decimal, 1 past, and it's 58.5. Now, the question is, I learned this. And that's something you should always ask in my class. What's the reason for learning this stuff? And I should always be able to answer that. And the question is answered by the following. Now here let's see. Oh, by the way, they call it elemental molar mass. Do not copy the slide down. Trust me, I'm a chemist. Does that work? How about trust me, I'm a doctor? Does that work? I'm both. All right. Now, there's 2 very important concepts in all of chemistry. I don't know anything more powerful. And that's called molar mass. And I'll never ask you these definitions, but I'll show you a better way to learn them. And that is elemental molar mass. The quantity in grams of an element equals the atomic mass of that element. That's one statement. Another statement, that's for elements. For compounds, the molecular molar mass, the quantity in grams of a formula mass or molecular weight of a molecule equals the formula mass. Now that's from your book. Let's make sense of that. I think I might have it on the next slide. This you should know. 1 mole of an element equals its atomic mass in grams. 1 mole of a compound equals its formula mass or molecular weight in grams. So if I said, go out and get me a mole of gold, well, you just look up the molecular atomic weight of gold, weigh that out, and bring it back to me, and I'd be happy. If I said, bring back a mole of water, well, you can't count Avogadro's number of molecules, because I don't know about you, but I've never been able to see a molecule yet. I can see a lot of them, but not one. And how do you do that? You weigh out the molecular weight of water. And let me write on the board once more. Now, in the past, I'd be writing on the board, hint, memorize this or learn it. On this one, hint, know how to use this. Again, I know nothing more powerful. 1 mole of an element equals its atomic weight in grams. 1 mole of a compound equals its molecular weight, which you just learned how to do, in grams. And therefore, I have a very important relationships. Now, one of the things that happens around now is students get confused. And they say, I thought you said 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd. And the answer is yes, it does. Well, how can it also equal this? Well, let's assume I had 12 tennis balls. How many tennis balls do I have? 12. Now, if they were always uniform, and I weighed 12 of them, I'd get a weight. I'm going to put a weight on the board to say 125 grams. It's probably more, but that's 12 tennis balls. So I could say, how many tennis balls do you have if you have a dozen? And the answer is still 12. How much does a dozen tennis balls always weigh? And this would be the answer. Well, the same thing is true for atoms and molecules. 1 mole of an element is Avogadro's number of atoms. 1 mole of a molecule is Avogadro's number in molecules. But now you know 1 mole of an element equals the atomic weight in grams of that element. 1 mole of a compound equals the molecular weight of that compound. And how do we use that? And today and Wednesday you'll find out. Now, some simple ones. Let's do what's the mass in grams for 1 mole of silver. And if we go to our periodic table, we find silver and the 3 significant figures. 1 mole equals its atomic weight in grams. So if I said, get me a mole of silver, you'd weigh out 108 grams, the 3 significant figures. And that would be 1 mole. If I asked for, let's say in the high rent district, a mole of gold, and we come down here, and the 3 significant figures, that would be 197. And that would be 1 mole of gold, which is also equal opposites. My grandmother trained me well. And anyways, that's for elements. Now, if we come back here, what's 1 mole of water weight? Well, earlier we calculated that. You'd have to calculate 1 mole of water, 2 hydrogens, 1 oxygen, 18.0 grams. So a mole of water is 18.0 grams. And if I asked, could you get me a mole of water, it'd weigh out 18.0 grams and bring it back in a beaker, and that would be 1 mole of water. Now, just like if I had a dozen tennis balls, it would weigh 125 grams. If I had a dozen cannonballs, would it be the same weight as the tennis balls, a dozen? No, it would be much heavier. Well, same thing with different compounds. You have to calculate the molecular weight. And if we look at ammonia, what would 1 mole of ammonia be? Well, we just calculated it, and that's 17.0 grams. Same thing for sodium hydroxide. See how sneaky I was using the numbers we just calculated? Sodium hydroxide, 1 mole equals the molecular weight, and therefore it's 40.0 grams. If I need a mole of sodium hydroxide, I'd go in the lab and weigh out 40.0 grams. And that's the really beauty of that. Now, one thing somebody always asks, and I'll answer it now, is what about other units? And you can use moles for the same thing. In this class, I'm going to be dealing with 1 mole of a compound equals its molecular weight in grams. I've done these calculations where you say 1 mole of a compound equals the molecular weight in kilograms or in pounds. Same thing, but I'll stay away from that in here. Make your life easier. Now, there are important things that you should know how to do. And here are a list of them. So let's go through one. And let's take the second one first, because that's more important. And let's do the following. How many grams of ammonia is 5.171 moles of ammonia? And before I do that, let me write up here. I can back up. Just have it on the screen. And here, 1 mole equals its molecular weight in grams. So, as you've learned from Dr. White before, me, you look at this and say, what am I trying to find, unit-wise? Grams of ammonia. What am I given? And as soon as I do this, I don't have to read this anymore. And I talked to you earlier, but it's time to use it again. It's time to use your good buddy, your good friend, unit analysis. Now, there's only one number I have to start with. Those many moles of ammonia. If I had some ratio, I could convert this to my answer. What units do I want my answer? And the answer is grams of ammonia. And now I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to, you put the units on top. Whatever I'm trying to get rid of, not the number, just the units, I put that underneath, because anything divided by itself is the number 1 that will cancel out. Where do I get these numbers? Well, if you look over here and on test number 2, you'll have that. That's in part my new philosophy to test your chemistry knowledge, not your memorization abilities. And we look at that and say 1 mole equals the molecular weight of the compound. Oh no, he didn't give us the molecular weight. And now you have to calculate it. 1 nitrogen, 3 hydrogens, 1 times 14.0, we did this before, but I'll do it again. 3 times 3.00, and now you have 14.0, 3.03, add it up, round it off properly, the answer is 17.0 is the molecular weight of ammonia, and we know 1 mole of a compound equals its molecular weight, therefore for every 1 mole, we have 17.0 grams. Remember, when you have 2 things, A equals B, you have 2 ratios, you can always write. And here I have 1 mole of ammonia equals 17.0 grams. And therefore I can do this now. Now, before I pick up my calculator, I'm going to check do my units cancel out. And if I just multiply the units, and what I'm going to do now, you don't have to do it on a test, but normally you should be able to do this in your head or on the paper. If I multiply just the units, this times this divided by this, you get this. Anything divided by itself becomes the number 1, and 1 times anything is that, and so I'm going to get the right units. And now, it's time for me to get my calculator out, courtesy of Bill Gates and Microsoft. Did I tell you I don't know Bill Gates? And now I'll put in 5.71 times 17.0, hit enter. Here's what my calculator gives me. Now, don't forget, use proper significant figures for all calculations. This is a multiplication division. You get the same number of significant figures to the answer as the number that you multiplied or divided, and it has the lowest significant figure. 3, 3. This is an exact number. It's a definition. 1 mole. By definition, this is always going to be 1. Therefore, it's exact. 3, 3. I have to round off to 3. How do I round that off to 3? Keep the 9, keep the 7. This number 7 is what I use to round off. That's 5 or higher, so I'll increase the 0 by 1. And I'm done. And if I needed 5.71 moles of ammonia, I would go to the lab and weigh out 97.1 grams. And that's how you do it. Now, let's look at this again, but first of all, this must be Friday the 13th. Battery change. Sorry about that. I know it's Friday the 13th, the dead battery. Now, this one's, here we go. Are you sure it's not Friday the 13th? All right, let's get back to chemistry. All right, if we look at this, we have the question, how many grams are so many moles? We know this. We have this number we're starting with. We're trying to get to this. We use unit analysis, put this on top, this on bottom. Where do we get these numbers? 1 mole equals the molecular weight, and you add it up and you get them, the molecular weight, you put the numbers in, and you do that. Let's do another one. And I'm going to do something called fading prompts. And the question is, what are you being asked to find and what are you given? I asked you to set it up yet. Just what are you being asked to find and what are you given? All right, let's take a look at this. And if I look at this, it says For those who can't read my handwriting, how many moles of water are 7.111 times 10 to the 4th gram of water? So what are we being asked to find? How many moles of water? What are we given? This. And now, how do we proceed? Well, there's only one number I have, this I no longer have to read, to work with, and that's this number. And if I had some magic ratio, it's not magic, it's chemistry, ratio, what units do I want to get to? I want to get to moles of water. And now, I use my good buddy, and soon to be your good buddy, unit analysis. Watch closely. Whatever units you're trying to get rid of goes on top of the ratio. Whatever you want to get to goes on top. Whatever units you want to get rid of goes underneath the ratio. And where do I get these numbers? 1 mole equals the molecular weight. He didn't give us the molecular weight. Well, you got to calculate it. And we did this already. Water, molecular weight is the sum of all atomic weights. 2 hydrogen, 1 oxygen. And I'm going to skip a step because we already did it. 2 times 101 is 202. 1 times 16.0, the atomic weight of oxygen is 16.0. Add it up. Drop that, and to 3 significant figures, or to 1 past the decimal, that's that. So for every 1 mole of water, how many grams of water are there? 18.0. And now, before I pick up my calculator, I'll use unit analysis again. Notice this would be grams times moles divided by grams. Anything divided by itself becomes the number 1, and I'm left with the right units. And now come over to my calculator. And my calculator gives me this number, and now I have to round it off. I'll let you try and round it off to the right number first, and then I'll do it. All right, let's take a look at this. How do you determine how many significant figures your answer should be? You look at the numbers you're multiplying and dividing, and the answer should have the same number of significant figures as the number you're multiplying or dividing. It has the fewest significant figures. This has 4, all non-zero integers are significant. All zeros past the decimal are significant. This has 3. What's the lower number? Hopefully I'll pick 3. How do I round that off to 3? Keep the 3, keep the 9, keep the 5. The 0 I use to round off, is that 4 or less? The answer is yes. So I now have 3.95 times 10 to the 3rd moles of water. So if you were to weigh out these many grams of water, that's how many moles of water I have. Now, one of the things I don't do, because it's not real life, instructors at this point sometimes would say a problem which I will never put on my test. If you have, let's say, 25 grams of water, how many molecules? Well, first you have to go from grams to moles, and moles to molecules. I have never done that calculation in all the years I've been a chemist, So why should I ask you to? They just put it on to put a hard problem on. It's not real life, so I don't. But these are. I've done these calculations many times, and I'll explain later in this chapter, next one, why you need to do something like this. Let's do one more. Now, before I let you loose on this one, let me remind you one mole of an element equals its atomic weight. And if we go over to our periodic table, you'll see sodium, I'm not going to round it off, is 22.990. Remember on my test, round it off to 3 significant figures. Why don't you try and figure out what are you being asked to find and set up the ratio equation to answer that. And I'll do it. By the way, you better look out. I think I'm up to 92.5% of knowing all your names, which is a good thing because you're no longer anonymous students, you're real people. I think everybody's about done. Let's take, I'll give you another 8.7 seconds. 2.7, time's up. All right, let's do this. First question is, what are you being asked to find? How many grams of sodium? What are you given? Trying to find how many grams, I'm given how many moles, and on test number 2 at the back, it will have important information plus a periodic table. And one of the things on that page will be 1 mole of an element equals its atomic weight in grams, and this should be in grams, of the element. And therefore, it's time for me to use my good buddy, my good friend, unit analysis. What did I tell you I'm going for Guinness Book of World Record, saying the most time in the next couple of weeks? I am. All right. This is the only number I have to start with. If I can write it properly. I have those many moles. If I can do in one ratio, what do I want unit-wise? My answer. Grams of sodium. And now I'm going to use my good buddy, my good friend, and has been for many decades, I wish I said that, But it's true. Whatever I'm trying to get to goes on top, unit-wise. Whatever I'm trying to get rid of, the units, goes underneath. Where do I get that number? Because you can find in the second to last page important information, and you know how to use this. 1 mole of an element equals its atomic weight in grams of the element. If we look over here, I have sodium. How do you round this off to 3 significant figures? Keep 2, keep 2, keep the 9, keep this 9. It's 5 or higher. Drop that. That increases by 1, which increases that by 1. So you got 23.0 grams. And now, before I pick up my calculator, I will now say, well, do my units cancel out? And get the right answer. Moles of sodium chloride, sodium divided by moles of sodium. Cancel out, I'm left with grams, because remember, anything divided by itself, unit-wise or any other way-wise, is the number 1. And now, I'll go ahead and pick up my calculator. And my calculator gives me this answer. Again, it will say on test 2, please use proper significant figures for all calculated answers. 4 significant, 3 exact number. How do I round that off to 3? Keep 2, keep 0, 0, use the 8 to round off. It's 5 or higher, drop that. This becomes 201 grams. So if I need these many moles of sodium, I go to the lab and weigh out 201 grams. And that's how I do it. Question?
There's a light on in your pocket, on the other one. It's like a red light. I think you have something on,
It is Friday the 13th.
but you might want to turn that off.
I have 2 flashlights on here. I'm into flashlights. They're not white because that doesn't ruin your night vision.
Oh, okay.
You sure it's not Friday the 13th?
It's
Let's see.
not.
Traffic, couldn't find the right chapter.
It's Monday the
My hearing aid.
30th.
Wait a second. They still work. All right, thank you for pointing it out, because that means my pocket won't explode now. Not really. All right. Let's do one more. These are good for your soul. Actually good for your brain. And let's do one more. And why don't you try this one out? I'll let you go ahead and do it all on your own, because I'm nice and I'll share. And let me remind you, and set it up. We already did the molecular weight of sodium hydroxide, but you should know that's the sum of all atomic weights. hydroxide. So I don't know what that means. Use Google. I sort of haven't, how should I say this, gotten around, and I don't want to using Google as a verb. I'll Google it, I just use it as a verb. All right, let's go ahead and do this. I think everybody's done. The first question you should ask is, what am I being asked to find, unit-wise? And the question is, how many grams of sodium hydroxide are 45.1 moles of sodium hydroxide? So we're trying to find grams of sodium hydroxide. What are we given? One number. And now, once I have this, I never have to look back here because this tells me everything I need to know. There's only one number I have to start with, and that's this. How many moles of sodium hydroxide? If I could convert this in one ratio to what? The units I'm trying to get my answer in. And guess what? It's time to use your good buddy, your good friend, unit analysis. And whatever you're trying to get to goes on top of the ratio, unit-wise. Whatever I'm trying to get rid of goes underneath, because anything divided by itself, which I keep on always erasing, equals 1. So I'm going to put moles sodium hydroxide. Where do I get that number? 1 mole equals the molecular weight. We did this, but let's do it again. You add up the atomic weights to 3 significant figures. Remember, you round off or get the proper significant figures only past the decimal, and the right answer is 40.0 for 1 mole, and therefore I put in 40.0. And now, before I pick up my calculator, moles of sodium hydroxide times grams of sodium hydroxide divided by moles of sodium hydroxide. Anything divided by itself cancels out. What units am I left with? The ones I want. I'm on the right path to victory. So, let's get our calculator out. And this is the number my calculator gives me. Let's put it in scientific notation, because most of you will have that. Your calculator in scientific notation. And this is what my calculator gives me. And if I look at this, I have 3 significant figures, 3. How do you round that off to 3 significant figures? Keep the 1, keep the 8, keep the 0. The number to round off is 4 or less. Is that 4 or less? Well, it's 4, so it is 4 or less. Therefore, this would be 1.80 times 10 to the third. And that's how many grams I'd have to weigh out of sodium hydroxide to get those many moles of sodium hydroxide. And now you know how to do this. Remember, your helpful good buddy, your good friend, is unit analysis. The 2 things that you should remember, and this will, you don't have to remember, but know how to use, is 1 mole of an element equals its atomic mass, or weight in the grams. For a compound, 1 mole of a compound equals its molecular weight in grams. And we'll be doing this in the practice problems, but essentially I've covered all of these, or most of these. See board for examples. I did that. So now I can move on. Now, we've already had a lab on this, but let's talk about this in the class. And that is conservation of law of conservation conservation of the mass. In any chemical reaction, the amount of matter in the reactants is always equal to the total amount. The dreaded T virus got me. You can't put it on a, I can't. Should be amount of matter in the products. So whenever you have a chemical reaction, whenever the total amount of weight of the elements has to equal the total amount and weight of the products. Because you never create or destroy atoms in a chemical reaction. I will never ask on a test, what is the conservation of mass? Oh, by the way, everybody in the back has everybody in front of you as witness. I said that. And what I'm about to talk about now is probably the most important thing I know in general chemistry. And that is, before I talk about it, let me put up a balanced chemical equation, because we'll need one. And we've already done balanced chemical equations in here. And if we look at this, we have the reactants at the base of the arrow, hydrogen, oxygen, and the product at the head of the arrow. Now, up to now, I would say, oh look, 2 hydrogen atoms react with 1 oxygen atom to make 2 water atoms. And that's true. But where the power comes in is now. And that is the coefficients, the number in front of a balanced chemical equation gives you the numerical relationship among formula units consumed or produced in the chemical reaction. What's more important is the one in red, which I wrote, the coefficients, and I'll never ask this in a test, but you should know how to use this. The coefficients in an equation, balanced equation it should say, give the fixed molar ratios between the substances consumed, the reactants, and the products produced, and it should be and, not or, in a chemical reaction. And again, I'll never ask this on a test, but watch closely. I'll wait until you all have a copy down. Oh, tonight at midnight, I'll be giving speed note-taking lesson. No, I won't.
No.
Looks like the last letter just went down. And let's see, is my flashlight still off? My hearing aids are working. Things are back on track. This is probably one of the most powerful things I know in all of chemistry. Watch closely. What this really means now is 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. The coefficients tell you molar ratios. Therefore, again, when the coefficient is not there, it's 1, this tells me, now you know, 2 moles of hydrogen react with 1 mole of oxygen to give 2 moles of water. So if I have 1 mole of oxygen reacting with an excess of hydrogen, when I say excess of hydrogen, that means you have all the hydrogen in the world to react with anything in this reaction hydrogen will react with. If I have 1 mole of oxygen, how many moles reacting with hydrogen, how many moles of water will I make? And the answer is 2. If I want to make 2 moles of water, how many moles of hydrogen do I have to start out with? And the answer is 2. So this tells you molar ratios. I'll give you an example. If we look at hydrogen, for every 2 moles of hydrogen, you make 2 moles of water. And the converse is true. For every 2 moles of water, remember numbers coefficient, you need 2 moles of hydrogen. I can do the same thing for oxygen. For every 1 mole of oxygen, coefficient, how many moles of water do I make? 2. And I know the converse. For every 2 moles of water, how many moles of oxygen I need? Coefficient is 1. The coefficients are molar amounts. I know of no other thing that's more important. Knowing this allows me to know how much chemicals of different things to mix together to make the correct amount of product. And therefore, if you think about the laundry detergent you made was made using this concept, your fabric softener, and I've made formulations for making a molecule of fabric softeners. The soap you use to make the plastic in here, you use this concept. I've used this concept to make chemical reactions where you're using up to 180,000 pounds, which is a lot. Did I talk about tank wagons in here yet? So that'd be about 4.5 tank wagons in one reaction put up this far. You don't want to make mistakes either. But let's look at how to use this. Say 5 or 8 points. Let me decode it for those who haven't figured out my handwriting yet. And that is how many moles of oxygen are needed to make 3.74 moles of water. So the first thing I'm going to do is ask, what am I being asked to find? And if I look at this, the answer is how many moles of oxygen. What am I given? This. 3.74 moles of water. What am I also going to be given for this kind of problem? You need a balanced chemical equation. And now, I'm going to, guess what? I'm going to say it again. Use your good buddy, your good friend, your analysis. What do I have to start with? And what am I trying to get rid of? Let me get up here. What units am I trying to get to? Come over here, and that's moles of oxygen. And now I'm going to use my good buddy, my good friend, unit analysis. Whatever units I'm trying to get to go on top. Whatever units I'm trying to get rid of go underneath. Where do I get those numbers? From a balanced chemical equation. 1 mole of oxygen makes 2 moles of water. Everybody see where I get that? The coefficients tells you molar amounts. And what this really means is 2 moles of hydrogen, 1 mole of oxygen make 2 moles of hydrogen. So if I want to find the ratio of moles of oxygen, moles of water, this is 1 mole. When there's no number, it's 1. That's 2. Now, this is very important. You can't go out and find half a molecule, because it's no longer a molecule. It's like you can't find half a car. Or, oh, quick, go to the store and buy me half an egg. You can't. Therefore, 1 and 2 are exact numbers and do not play a role in significant figures. Therefore, my answer, I start out with 3 significant exact number, my answer will have 3 significant figures. And before I pick up my calculator, I'll use unit analysis again. And if I come here, moles of water divided by moles of water become the number 1. Cancel out, I'm left with the right units. And now I'll go to my calculator. And this is what my calculator gives me. Let's do one thing. That's pretty simple. I usually don't hit it on the head. And the 3 significant figures, the answer is 1.87 moles of oxygen. Now, why don't you try this one? How many moles of water are formed when you react 8.11 moles of hydrogen with an excess of oxygen? Why don't you just try and set it up, and then I'll show you. First of all, what are you being asked to find? What are you given? And use your good buddy unit analysis, and don't forget the balanced chemical equation. Now we're getting into some good chemistry. Okay, 25 seconds more because the clock is ticking. I got batteries, I can hear it. All right, let's do this. What are we being asked to find? How many moles water? What are we given? 8.111 moles hydrogen. We're also given the balanced chemical equation, which tells me 2 moles of hydrogen after 1 mole of oxygen to make 2 moles of water. There's only one thing I have to start with. What units do I want to get to? I'll now use unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And where do I get those numbers? For every 2 moles of hydrogen, I make 2 moles of water. I better get my calculator out. I think you all know. Remember, these are exact numbers. Moles divided by moles hydrogen cancel out. Left with moles water. I can do this in my head, I think. 4 significant, exact 4 significant. And with that, I went a whole 30 seconds late. I'll see you on Wednesday.